Let's see example 1.1. Example 1.1 asks us if 10 to the power 9 electrons move out of a body to another body every second. How much time is required to get a total charge of 1 coulomb on the other body? After there is no problem to understand the question. To solve this question, I am going to take the help of the figure. Let's see the relevant figure. First of all, I will write down here solution, and this is the first body. Name of the first body is A, and this is the other body. The name of the other body is B. Electrons move from A to B at the rate of 10 to the power 19 electrons per second, which is given in this question. When we convert 10 to the power 19 electrons per second into charge, then this one will be 10 to the power 9 into charge on 1 electron, which is 1.6 into 10 to the power minus 19 coulomb, and we write down here per second. After there is no problem to understand up to this step, therefore here will be 1.6 into 10 to the power 9 into 10 to the power minus 19 equal to 10 to the power 10 coulomb per second. After there is no problem to understand up to this step. So how much time is required to get total charge of 1 coulomb on the other body? So required time here will be required time to get a total charge of 1 coulomb on the other body B will be, we write down here 1 coulomb by, we write down here 1.6 into 10 to the power 10 coulomb, and we write down here seconds. Cancelled out coulomb coulomb, then we get here 10 by 1.6 into 10 to the power 9 seconds. When 10 divided by 1.6, then we get 6.25 into 10 to the power 9 seconds. From solution it is clear that 6.25 into 10 to the power 9 second is required to get a total charge of 1 coulomb on the other body B. So after there is no problem to understand the solution as well as the explanation of the solution of this question. If you have any doubt to understand the explanation as well as the solution of this question, then write into the live chat box, which is open to all of you. I will try my level best to clear your doubt on a spot. Let's see the example 1.2. How much positive and negative charge is there in a cup of water? Let's see the solution of this question. So let 1 cup of water has 36 gram water. So we find out the molecular mass of the water. So molecular mass of the water equal to, here will be molecular formula of the water is H2O, so here will be 2 into 1 plus 16 equal to 18 gram. Therefore 18 gram H2O equal to 1 mole H2O. Therefore 36 gram H2O equal to 1 by 18 into 36 equal to 2 moles H2O. Up there there is no problem to understand up to this step. Again we know that 1 mole equal to 6.023 into 10 to the power 23 coulomb charge. Therefore 2 mole equal to 2 into 6.023 into 10 to the power 23 coulomb. So H2O has 10 electrons and 10 protons. Therefore total positive and negative charge and negative charge in a cup of water of mass 36 gram equal to, here will be 2 into 6.023 into 10 to the power 23 into 1.6 into 10 to the power minus 19 into 10. So here will be what? After the multiplication we get here 1.6 into 2 equal to 3.2 and 3.2 multiplied by 6.023 into 32 3.2, then we get here 6 4 0 and this is the 12 9 6 0 and this is the 18. So here will be 6 13 7 2 9 and this is the 1 3 and 1 4 1 2 3 and this is the 4. So we write down here 19 into 2 7 3 6 into 10 to the power minus 19 10 to the power 10 and 10 to the power 23 10 to the power 23 plus into 10 to the power 1 equal to 10 to the power 24 and 10 to the power 24 minus 19 equal to 10 to the power 5. So when this one is divided by 10 then we get 1.9 and we write down here 3 and divided by 10 and multiplied by 10, so we write down here 10 to the power 6 coulomb. So after there is no problem to understand the solution as well as the explanation of the solution of this question. If you have any doubt to understand the question, solution, explanation of the solution, then write into the live chat box which is open to all of you. Let's see example 1.3. Coulomb's law for electrostatic force between two point charges and Newton's law for gravitational force between two stationary point masses. Both have inverse square dependence on the distance between the charges and masses respectively. A. Compare the strength of these forces by determining the ratio of their magnitudes. 1 for an electron and a proton, and 2 for two protons. B. Estimate the acceleration of electron and proton due to the electrical force of their mutual attraction when the are 1 angstrom equal to 10 to the power minus 10 meter apart. Mass of proton is 1.67 into 10 to the power minus 27 kg, and mass of electron equal to 9.11 into 10 to the power minus 31 kg. So let's see the solution of this question. So in a ask us compare the strength of the forces by determining the ratio of their magnitude. It means that electrostatic force by gravitational force. So electrostatic force will be 1 by 4 pi epsilon naught into 2 point charges. Newton's law for gravitational force between two stationary point masses. So here will be charge on electron into charge on proton. So this is the attractive, therefore we write down here minus by distance between electron and proton. By we write down here minus g, gravitational constant. This is the, and mass of electron into mass of proton by distance between mass of electron and mass of proton. So after the calculation we get this one. So this formula is the useful to find out determining the ratio of their magnitude. 1 for 1 electron and 1 proton. It means that electron and proton has same charges but mass are different. 2 for 2 protons. For 2 protons it will be electrostatic force by gravitational force. Then this one will be, then force will be repulsion, therefore we write down here plus 1 by 4 pi epsilon naught into both proton has same charge, therefore we write down here q square by r square. By gravitational force it will be gravitational constant, and both are proton, therefore we write down here mp square by distance between two proton which is r square. So this one will be the a to 1 and this is the a to 2. Again in B, estimate the acceleration of electron and proton due to the electrical force on their mutual attraction. So we find out electrostatic force between electron and proton, it will be minus 1 by 4 by epsilon naught into k square by r square, and according to the second law of motion, force on electron will be mass of electron into acceleration on electron. So here will be a electron, acceleration of electron equal to will be me move in the left hand side, then we get here 1 by 4 pi epsilon naught into k square by r square, and here will be mass of electron. Similarly, uh, acceleration on proton will be electrostatic force between electron and proton, which is minus 1 by 4 pi epsilon naught into k square by r square, by here will be mass of proton. So we write down here into 1 by mass of proton. After that, there is no problem to understand the solution as well as the explanation of the solution of this question. After putting the value of Q, R and ME and AP, we get the answer of these questions in figure or numerical form.